Hello, good evening. Welcome to the course of Power Electronics, Circuits, Devices and Application. Today, in this lecture, we are going to cover the idealities and non-idealities of switches, and then we will see certain design parameters and consideration that should be kept in mind before choosing a switch for different applications. So, let's start. To start with ideal switches, here we can see there are two switches displayed in front of you. One is in off state and other switch is in on state. So here during the off state, you can see the switch is not connected to this pole. So here you can see the throw is connected to the pole. So this is on state. So during on state and off state, you can see we have two states where the switch can either be uh, during the off state, the current path is not available, so there is no current which is going to be flowing across the switch, whereas there will be some finite amount of voltage and ideally it should be infinite. So we can say off voltage during the off state should be infinite. Whereas during on state, you can see when the pole is connected across the throw, there will be certain amount of on state current which will be passing through the switch. And then during the time when it is shorted, there should not be any voltage appearing across the switch. So ideally, on state voltage of a switch should be zero. So here we can see some of the ideal characteristics such as infinite on state and off state voltage, zero off state and on state voltage. During some of the conditions we can see it should not take ideally any time to turn on and turn off. It should be instant. Then it should not be impacted with the rise of the temperature, or there should not be any change in temperature. Then next is it should not require any kind of energy or dissipate any kind of energy during the time it is turned on or turned off. So it should maintain its state. Then next is it should have infinite power to weight or power to volume ratio, and ideally zero or cheap cost, we can say. The ideal switch should have these characteristics. Next, looking at the characteristic of ideal switch, we can say that the ideal switch, when on the x-axis we can observe we have a voltage line here. So ideally it should block infinite positive voltage, infinite negative voltage, and then it should allow basically infinite amount of positive and infinite amount of current in the negative direction during the on state and off state. So this is, if somebody asks what is the ideal characteristic of a switch, that means it should be able to carry infinite amount of current and infinite amount of voltage. So here you can see during on state, infinite amount of current should be passed. During off state, it should block infinite amount of negative current. Next, if we'll observe the ideal switch, it can be of two categories. One is single pole and double throw switch, which you can see here, where two throws, throw 1 and throw 2 is connected to a single pole. And this kind of configuration is generally used in buck converters, which we will see in later classes. But next here you can see a single pole triple throw switch, where the pole is connected to three states, throw 1, throw 2 and throw 3. So we will see certainly some of the examples where such kind of conditions also comes in picture. So these kind of ideal switches are available, and then let's see the non-idealities with the switches. So when we discuss the non-ideality of a switches, of course the condition that we have seen earlier, such as on-state current and off-state voltages, they are not infinite. Now they are some finite values and they are having some limited values, and which are basically termed as blocking voltage and limited capacity of current. So these red lines here you can see plus V limit and minus V limit. It shows the positive and the negative limit of voltage that can be blocked and passed across the switch. And then you can observe the green lines plus I limit and minus I limit, that shows the positive current and the negative current limit that a switch can withstand. And these lines here, P limit you can see. So once you will see all these lines which are there crossing here, this makes the safe operating area of a switch. So on and off states are not non-zero values, they have certain finite values. And during on state and during off state, there will be certain losses which are finite in number. And then during on and off state, the time for those values are also not zero. So there are certain switching losses. They are called as switching losses. And then of course the devices also uh, derive some energy, and these losses are during calculated in the drive circuits. And then of course the power and the thermal limits are also limited. So the device should ideally be operating in safe operating area. If we observe the device is working perfectly fine in safe operating area, it will be working very well and fine. Else, if it goes beyond this, there are chances the device may burn off. Now, let's see certain design consideration, and for that we need to understand the three states of switching for each switches. So each switch will have its static stage where we talk about on and off state of that circuit. Then next, we need to discuss about the dynamic stage, and in dynamic stage, the transition or commutation process is happening. And during all these stage, energy losses are there. Current ratings which has to be considered during the on state is continuous current for the worst case design scenario. Average current has to be considered during on state loss, RMS current during on state losses, and peak current is required to understand the local heating and metal contacts. Then current time values are required for peak current for short duration, which is also called as duty cycles. So these are certain design consideration that is required to be kept in mind while choosing any switch. Now let us see the practical uncontrolled switch. And the term uncontrolled means user don't have a control over the on and off state. So here the operating quadrants are forward conduction during the forward conduction stage here, which is represented during the first quadrant where VAK and I is presented here. So during this time, forward conduction is happening, and the next operating state is during the reverse blocking stage. So these are the operating quadrants here. For diodes, usually it operates in only in the first quadrant when the knee voltage is basically after the knee voltage, there is a rapid rise in current, and these kind of devices basically they can be PN junction, pin type or Schottky type of diode. The current ratings which are available is from 1 ampere to 5000 plus amperes now, and the voltages that starts for is 10 volts to 10 kilovolts. And then switching speed is from basically 20 nanoseconds to 100 nanoseconds. For choosing any data diode, you need to go through the data sheet of that diode, and then you will be able to find out the right amount of voltage and current which is required for the application. So if we discuss about the non-idealities, RD, VF, IOF and VPIV are the certain factors that is required to be considered during choosing the circuit. And some other important specifications such as forward current, then off-state voltage, off-state, on-state voltage, and uh, reverse recovery time, I square T, this has to be kept in mind, and we will see in complete details when we discuss about the switches. This is basically the introduction, and then moving ahead, there is a practical semi-controlled switch which is also termed as silicon controlled thyristor. So here on the symbol you can see anode, cathode, and uh, through gate we can control basically the turn on stage of this kind of a switch. So next you can see this is basically 4-layer 3-junction device where PNP and NPN transistor back in back when they are connected in this position, in two transistor analogy, they usually form SCR. So it is basically a charge or current control device and operating in forward conduction mode, forward and reverse blocking mode. The voltage and current which is available for this kind of devices start from 1 ampere to 5000 ampere, voltages from 200 volts to 600 volts. So basically it is used for the high power application device. And then important specifications which has to be considered while choosing is forward current and forward voltage, I of di by dt, dv by dt, I square t. So also while choosing the characteristic, we need to observe the static and dynamic characteristic of this device. And there is a data sheet which is presented here, which shows basically some of the consideration that we will see once we will go in detail in discussing each device. So here in this characteristic, you can see there are certain values which are termed as latching current, holding current. So all these values we will see in the next lectures, how these are important. Then next we can see there is another practically controlled switch which is called BJT, which is a three terminal device like base, collector and emitter. So here base region is wider than small signal BJTs. It is a current control device and it provides a low current gain, which is basically which helps in increased drive power requirement, losses and provides slow switching generally. The current specification starts from 0.5 ampere to 500 amperes, 30 volts to 1200 volts, and the timing is from 0.5 seconds to 100 seconds, and it operates during forward conduction and forward blocking mode. Next is another practical switch which is termed as MOSFET, and here you can see it's a three terminal device which is represented by G, D and S, where G stands for gate, D stands for drain and S stands for source. So this is a voltage control device which offers low drive power requirement and fast switching, and operating quadrants are forward and reverse. It basically comes in the range from 1 to 100 amperes, 30 to 1000 volts. And since this is the fastest switching device, you can find the range in nanoseconds starting from 50 nanoseconds to 200 nanoseconds. And then important specification to be observed while choosing a device are drain current and RDS on state time, off state time, VGS threshold, etc. And some of the important data sheet that you can download and check is IRF 640 and IRF 840 for your reference. Next is IGBT, which is a combination of characteristics from MOSFET and BJT. So it is also a voltage control device like MOSFET, three terminals, gate, collector and emitter, which it is basically faster than BJT, but it is slower than MOSFETs. The operating quadrants are forward conduction and forward blocking, starts from the range of 10 amperes to 1200 amperes and 600 volts to 3300 volts. So basically the power requirement, you can see it's high, and of course its switching speed is better than BJTs, but it's slower than MOSFETs. So up to 500 nanoseconds, it's well and good. So today we have seen a variety of controlled and uncontrolled switches. In the next class, we will start in detail analysis for each kind of switches and then their applications. So thank you for joining today's session.